Hello, this is a video on finding stationary points and determining their nature. Okay, now first of all, I just want to go through quickly what a stationary point is before we go into finding them. Okay, so conceptually, curves do one of three things that results in a stationary point. They go up, they stop going up, they hit a zero of up and down, and then they go down. So their gradient goes from plus, goes through zero, and then minus. Because if it's heading up, it stops, then it heads down again. There's got to be a point where it's going not up and not down. It's just stationary. Okay? Now we know that there's movement from left to right, but the up and down movement is stationary. Okay, so this one that I've drawn that has a positive, zero, and negative gradient is a max. Okay, there's obviously the sort of happy face to its frowny face, which is one that goes minus, stops at zero, and then has a positive gradient, and that's called a minimum. Okay, the final one, our third type, is a point of inflection, and it's where the curve goes up, stops going up, then starts going up again, or goes down, stops going down, then goes down further. Okay, now in these examples we're only going to be looking for a max and min, but you might also be asked for a point of inflection. Okay, and these sort of notes are something I would definitely put straight on my summary sheet. Okay, with that in mind, what we're looking for is something that will tell us how fast the curve is moving up and moving down, and then naturally we can solve it for when it's not moving up or down, which should be zero. And luckily we have that in the form of a derivative. So like everything in this unit, our first job is to find the derivative. Okay? Which, for the question I'm going to do, which will be, let's go straight to f. Okay? So the derivative in f, the equation is y equals x outside of x squared minus 27. Okay, now what I'm going to do for this equation is expand it first so I can find the derivative. Okay, because it's easier to find the derivative in the expanded form with polynomials. Okay, so we go y equals x cubed, or x times x squared, minus 27x. Okay, then what we do is we find the derivative. So y dash, our derivative, equals 3x squared, okay, minus 27. Okay, and this is our derivative. So it's moving in that pace. Okay, so if we want to find the gradient at a point, we just sub it in for x, and we can find the gradient by squaring it, timesing that number by 3, and then taking away 27. Okay, now key with this is we don't want to sort of use x to find a gradient. We want to use a gradient, namely 0, to find x. So we substitute y dash for 0, and we end up with 3x squared minus 27. Okay, now all we need to do is factorize out the 3 to make it a bit simpler. So we end up with 0 equals 3 outside of x squared minus 9. Okay, and now we know that sort of what squared equals 9? Well, x equals 3. Okay, and the reason I know that is this is 3 times something in brackets, so I use my null factor law. I want to make the brackets 0, and what squared take away 9 gives me 0, well 9's take away 9 gives me 0, and 3 squared is 9, which is the logic behind that. Okay, so I know that x equals 3 is my turning point, where this either has a maximum, hits 0, and then goes down again, so plus 0 minus, or a minimum turning point, where it is a minus gradient, then a 0 gradient, then a plus gradient. And I've got to work out which one it is. Okay, so now I put the gradient, which just to remind you is this function, okay, and I use a table to find several values of that function, okay, and then that table will tell me which one it is. Okay, now because this has only one turning point, I only need, I can put in pretty much any numbers I like into the table. Okay, but say it had 2 turning points. Say it had a turning point at 3 and then at 1. Well, I need to use the value in between 3 and 1 to make the table work. And I'll show you why that is in a later video. Okay, so let's get started with our table. Okay, so pick a value for x. Sorry, pick a row for x. Then we're going to use the numbers 2, 3, and 4 because they're close to 3 and either side of 3. Okay, then we do our y dash for these values. So we chuck 2 into our formula and see what we get out. Okay, so 2, I'll just solve it down here. 3 outside of 2 squared minus 27. Okay, now 3 times 2 squared is 4. So we end up with 12 minus 27. Now 12 minus 27 is a negative number, and I'm just going to put the sign in there. Okay, then at 3 it's 0. That's what we determined down here. And then at 4, it's 4 squared minus 27 times 3. So 4 squared is 16 times 3 is more than 27. So it's going to be a positive number. Okay, so now I know that it heads down, hits 0, and heads back up. So I can say that my x equals 3 is a minimum. Okay, it's a stationary point and it's a minimum. Okay, hopefully that shows you the procedure. Key things are finding the derivative, substituting 0 for the derivative, and finding where the derivative equals 0, and then using the table to determine if it was a maximum, a minimum, or a point of inflection. Okay, so now that you've seen the first example with F, I want to take you through C. Okay, if you'd like to have a go yourself, and I'd encourage you to do this, pause the video, and if you can do it, skip to the end and see if we get the same answer. Or if you sort of struggle, then watch the video. Okay, but it should give you a good sort of understanding of it, having a go yourself, okay, and seeing if you can just nut the problem. Okay, so assuming you've had a go yourself, I'll give you my take on it. Okay, so just first step is to write it down. So we're doing C, which is, I'll do it in black just to show you it's a different question. C, y equals 2x cubed minus 3x squared minus 36x minus 2. Okay, just like before, my first step is now to find the derivative. Okay, so I do that by just using the power rule, which is take the index times it by the coefficient and take 1 off the index. Okay, so if y equals this stuff, y dash, or the derivative, is going to equal 6x squared minus 6x minus 36. Okay, now my second step is to solve for 0. Okay, but the first thing I'm going to do is set that to 0. Then I can factor out 6. Okay, I can divide everything by 6. So I divide 0 by 6 and get 0. I divide x squared by 6 and get x squared. I divide minus 6x by 6 and I get minus x, and 36 by 6 and I get minus 6. Okay, and that just makes the problem a bit easier to see. Okay, now I can go through and use the quadratic formula, but I don't think I need to here because I can just use the fact that what two numbers times together to give minus 6 and add together to give minus 1, well, that's going to be minus 3 and plus 2. So my brackets look like this. And using the null factor law, what times is together to make... using the null factor law, I need to make one of or both of those brackets 0. Okay, so x, what minus 3 makes 0? Well, 3. So x is going to be positive 3 or negative 2, because negative 2 plus 2 makes 0. Okay, so it's the opposite sign of these terms here. So we've got our x values of x equals positive 3, okay, or negative 2. Okay, so those points, there's a turning point. Okay, now something I didn't do in the earlier video and should have is solved for y values, because a point is not just the x value but the y value as well. Okay, so I'll do that now. Okay, so for this point at 3, we've got 3 cubed. I'm just substituting into the original equation to get y values for these points and make these points not just x values. So we end up with 2 outside of 3 cubed minus 3 times 3 squared minus 36 times 3 minus 2. Okay, which is 27 times 2, which is 54, minus 27 minus 36 times 3. Sorry, I'm cheating. 3 times 36, 108, minus 2. Okay, then 54 minus 27 minus 108 minus 2. Okay, and you can work out the second one. For the sake of time, I'm going to skip that step and just go on to the nature of the turning point. Okay, so you've got 2 x values for your turning points, and you need to know whether they're maximum or minimum. Okay, and instead of doing one table like we did for the last table, because there's 2 of them, I don't want to do 2 tables, I just want to do a bigger one. Okay, and I'll show you why in a second. Okay, so you've got the values -2 and 3. Okay, so sort of like the curve does something at -2 it's 0 and at 3 it's 0. Okay, so I need to start off with a value less than -2, which I'll go -3. So these will be our x values, -3, -2. Then I'm going to pick 0 because it's in between -2 and +3. I've got +3, and so it's going to be +4. Okay. Then I'm going to find my my y dashes, my derivatives at those points, using my derivative equation that I found earlier. Okay, 64 plus 18 minus 36 gives me a positive value. Okay, then -2 should be 0. Okay, because we've already worked that out as 0. Then we've got 0, which should give me a negative value. Then we've got 3, which should also be 0. And then we've got 4, which I'm thinking will give me a positive value. Okay, so 4 squared is 16 times 6. Yep, that's definitely going to be positive. Okay, so now we know that the curve goes positive, it stops. Sorry, that was the wrong way around. It goes positive, it stops, it goes negative, it stops, then it goes up. Okay, because it's got zeros at 2 and 3. Sorry, zeros at -2 and +3. Now notice I needed to know the 0, the value in between those. Because if I'd picked either side, I would have had plus and plus, and I would have thought that together they were some sort of weird point of inflection. So when you've got 2 turning points or 3 turning points, you need values in between the turning points so that you don't stuff yourself up. Okay, hopefully that was helpful. Bye guys and girls.